Dear learner, I welcome you all to the program Postgraduate Certificate in Industrial Safety. I am Dr. Sanjay Agrawal, Associate Professor in Electrical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, and I am also Program Coordinator of this program. In previous session, we discussed basic of the electrical system, like we have discussed what is a conductor, what is an insulator, type of current, like AC current and DC current. Then we have also discussed different component of electrical system like resistance, inductance, capacitance, coil, and what is the importance of fuse. In this module, we are going to discuss need for safety of electrical equipment and what safety precautions should be take when we use different electrical equipment. Equipment designed for high voltage capacity such as transformer, circuit breaker and instrument transformer. Instrument transformer means it may be the current transformer or it may be the voltage transformer. These instruments can create hazards to the human health, which is why it is important to prioritize safety measure with its operation of maintenance. Avoiding safety precautions lead to equipment failure and injuries which can shine a negative light on your organization. Generally, all electrical machines and power electronics equipment involve electrical current, voltages, power and energy quantities that should be handled with highly diligence and care during experiment and operations. Electrocution happens when electrical path is established through the body with very low current that can damage vital organs such as person's heart and may cause immediate death. All experiments must be performed in the presence of expert trainer to handle electricity at this high voltage and current level. So after going through this module, you should be able to describe the basic safety steps to be followed while working with electrical equipment, and you will also be able to explain the safety precautions during working on different type of electrical equipment. These electrical equipment may be the transformer, maybe the circuit breaker, different instrument transformer like voltage transformer and current transformer and all that. So now we are going to discuss principles and procedure for safety of electrical equipment. The safety precautions includes major guidelines and precautions to perform safe lab and operating environment for persons performing experiment on electrical equipment. These guidelines include all necessary precautions, local electrical safety rules and regulations that should be followed. Experiment on electrical machines and power electronics generally use common equipment to supply power and to measure electrical quantities. However, circuit and apparatus being tested may vary for different experiments. Now, what safety precautions we should take care? Now, I am going to discuss safety precautions. In all electrical power and experimental setup, the following safety precautions must be considered. First one, loose wire, cables and connection must be avoided. Second one is what? No exposed metal is live with the electricity. All on-off buttons on equipment, circuit breaker and disconnect switch of a bench must be familiarized. Circuit power is turned off before make any changes in the experimental setup. Use suitable length of wire in the experimental setup. Long wire or connection can cause clutter on a bench, and short wires or connection can be too tight and may be easily disconnected. Next is isolate high power equipment and connection from low power equipment such as microcontroller to avoid interference and electrical interconnection between sensitive electronic devices and high power devices. Noted that all DC power supply, AC sources and power sources start from 0 voltage and 0 current output or as instructed in the experiment. Initial non-zero voltage is possible in some applications where a voltage source should have a specific starting condition. Before leaving the lab, all electrical equipment must be turned off. You have to take care this point very carefully. Avoid single user to perform an experiment. always try to have at least 2% when you are working on some experimental setup. More than 2 users perform an experiment when performing on more than 50 volt DC and 3 phase AC. Now we are going to discuss about the work environment. So familiarize oneself with all available equipment in the lab. Cluttered work environment must be avoided. Arrange pen, calculator, lab notebook and experiment description before performing experiment. Label cool and warm equipment separately. It is due to the heat dissipation. Now we are going to discuss what precautions should take care about the clothing and personal requirement. Avoid jewelry, metal watches or other metal accessories when performing any experiment, as this can be dangerous in the vicinity of rotation machinery and electrical connections. Avoid wearing loose apparel, shorts or short skirts, as they expose direct skin to electrical connection and rotation machinery. Avoid wearing hanging necklace, glasses, ties and other accessories, as users tend to get close to rotating machinery and electrical connections. Long hair should be tied to the back of the head. Wear personal protective equipment as required by the local safety rules and regulations. For example, common personal protective equipment include fire retardant coats, high voltage insulating gloves and earplug when you are working on operating loud machinery. Now we are going to discuss safety precautions for using basic measuring equipment. Some of the most frequently used test instruments include non-contact voltage tester, multimeter, insulation tester and ground resistance tester. A big issue with using non-contact or proximity devices, for example, is that to prove a circuit is de-energized, it is necessary for that circuit to be tested face to face and face to ground, which cannot be done using this type of tester. Due to the potential electrical hazard associated with the use of electrical test instrument, only qualified persons are permitted to perform tasks such as testing, troubleshooting and voltage measuring when working within the limited approach boundary of exposed energized electrical conductor or circuit part operating at 50 volt or more, or where any other electrical hazard may exist. Improper use of electrical test instrument can result in shock or electrocution as well as creating an arc flash incident. The following requirement apply to the test instrument, equipment and all associated test leads, cables, power cords, probes and connector. So first point is what? You must be rated for the circuit and equipment where they are utilized. These instruments must be designed for the environment to which they will be exposed and for the manner in which they will be utilized. It must be visually inspected for external defect and damage before each use. If there is a defect or evidence of damage that might expose an employee to injury, the defective or damaged item shall be removed from the service. When test instruments are used for testing the absence of voltage for de-energized work on conductor or circuit part operating at 50 volt or more, the operation of the test instrument must be verified on a known voltage source before and after an absence of voltage test is performed. Now various measuring equipment with safety precautions is discussed in detail. So one by one we will discuss all these measuring equipment. So this verification primarily applies to the conductor or circuit part operating at 50 volt or more, as I already told you this. However, under certain conditions such as wet condition or immersion, even circuit operating under 50 volt can pose a shock hazard. So first instrument that we are going to discuss, that is a megger. So question arises, what is a megger? Megger is an electrical instrument that is used for testing insulation resistance and machines winding to safeguard all electrical equipment from major damage. So basically measure is what? Measure is used to measure the high resistance in terms of the mega ohm. That's why it is called measure. So this is the schematic diagram of measure. You can see here, you can see that pole place, current coil, angular iron ring, and here you can also see that's a hand driven generator, and where you have to measure the resistance, or you can say insulation resistance. You can put that insulation resistance here as shown in the unknown resistance. Then here you can see that three resistance which are shown as multiplied by 1, that means resistance product multiplied by 1, and resistance multiplied by 10, and resistance multiplied by 100. So by using this instrument you can measure the high resistance of any cable, or you can measure the resistance of insulation of any cable or cord. So what is a measure test procedure? What you have to do? To measure electrical leakage in the wire, we pass the current through device, then we verify the electrical insulation level in any device such as motor, cable and transformer. The result of this can be measured in terms of mega ohm. Now we have to understand working of the measure, how measure work. For electrical system whose voltage is high, it requires 1000 volt to 5000 volt for testing. Connection of deflecting coil must be in series so that the current that flows test the circuit. The circuit is connected with the pressure coil across it. To protect the circuit, two resistors, that is current coil resistor and pressure coil resistor, are connected in series, and also using two coils like control coil and deflecting coil. In a manually operated measure, a test voltage is generated by the EMI effect. When the voltage increases, then the deflection pointer shows to infinity. Similarly, if current increases deflection, the pointer shows 0. Therefore, the torque is directly proportional to the voltage and torque is inversely proportional to the current. You also note that in case of short circuit, the pointer indicates 0 reading. Now what safety measure should be taken while using the measure? When measure is used for testing purpose, injury or damage equipment, if the following minimum safety precautions are not observed. So what you have to do? Use measure on high resistance measurement only, such as insulation measurement, or to check two separate conductor on a cable. Never touch the test lead while handle is being cranked. De-energize and discharge the circuit completely before connecting a measure. Disconnect the item being checked from other circuitry if possible before using a measure. Now we are going to discuss about the next measuring instrument, that is called multimeter. You are very familiar with the multimeter. Multimeter means it is used to measure the voltage, current and resistance also. So a multimeter or multi-tester, also known as VOM, that is a voltage, ohm, milliammeter, and it is an electronic measuring instrument that combines several measuring functions in one unit. A typical multimeter can measure voltage, current and resistance as shown in figure. Multimeter is also used for continuity check and for various electronic component testing purpose. Continuity check means suppose there is a one wire, and suppose wire is broken inside of the insulation, and you have to check whether it is a proper connection or not. So that means you have to check the continuity check by the multimeter. Now we are going to discuss about the continuity check. Before starting any measurement activity, you should check the multimeter for continuity. For this, connect its leads and confirm that it reads 0. When performing continuity check for a circuit, switch off the power supply to the circuit. If there is a capacitor in the circuit, you will hear a beep sound until the capacitor drains. Always confirm the presence of the capacitor to avoid any confusion. If you change the lead between red and black, the reading should not change. Now we are going to discuss about the voltage measurement with help of the multimeter. While measuring voltage, never touch the bare probe tips together as it will lead to short circuit. Many digital multimeter have auto ranging facility so that you need not worry about overloading, but it makes them work slower and it increases their cost also. If auto ranging is not available, appropriate range should be selected so that multimeter reading is near midway on the scale. You should check for DC voltage and AC voltage modes in your digital multimeter, whether these are separate. Check the user manual to confirm. If lower range is selected, the multimeter shows, which means that actual reading is out of selected range. If required voltage for DC circuit is not known, start from the highest value and go down until correct range is identified. If you forget to put the red lead into appropriate socket for voltage measurement and the red lead is connected to the current socket in the multimeter, a voltage measurement in this situation may lead to a short circuit through the multimeter. Now we have to check how the current is measured with the help of the multimeter and what precautions you should take care when you are using multimeter for the current measurement. For current measurement, the multimeter should be connected in series while it should be connected in parallel for the voltage measurement. When multimeter knob is set to current measuring mode, you forget to change it to voltage measuring mode before taking voltage measurement. It may be a cause of potential hazard. Set the right current range before measuring higher current, otherwise it will blow the digital multimeter fuse. Don't try to measure the current in household AC mains as it is very dangerous. Now, as I told you that resistance can also be measured with the help of the measurement. Now we will discuss how the resistance is measured and what precautions you have to take care when you are measuring the resistance with the help of the multimeter. Power should be turned off before taking any measurement. A resistor should be measured standalone, otherwise connected component in the circuit may affect the reading. If you still need to measure a connected resistor, ensure that any capacitor in the circuit are drained off. Now we are going to discuss safety precautions when you are using the multimeter. As with other meter, the incorrect use of multimeter could cause injury or damage. The following safety precautions are the minimum for the using a multimeter. When using digital multimeter, we should be careful and observe few safety precautions in order to keep ourselves safe. We should also follow general precautions during using of multimeter, which are as follows. So first point is what? When not in use, keep the digital multimeter knob in off position or highest voltage position. Second point is what? If you want to check presence of hazards voltage in a circuit with a digital multimeter, it is important to check for both AC and DC voltage. Now we are going to discuss about the next instrument, or you can say device, that is a power supply. A power supply is an electrical device that supply electrical power to an electrical load. The primary function of power supply is to convert electrical current from a source to the correct voltage, current and frequency to the power the load. As a result, power supplies are sometimes referred to as electric power converter. Some power suppliers are separate stand-alone pieces of the equipment, while others are built into the load appliances that they power. Example of the latter include power supplies found in the desktop computer and consumer electronic devices. Other functions that power supplies may perform include limiting the current drawn from the load to the safe levels, shutting off the current in the event of the electrical fault, power conditioning to the prevent electronic noise or voltage surges on the input from the reading the load, power factor correction, and storing energy so it can continue to power the load in the event of a temporary interruption in the Source power. All power supplies have power input connection which receives energy in form of electric current from a source and one or more power output connection that deliver current to the load. Basic power supply here you can see as shown in the figure. Now what precautions should we take care for the safe use of that power supply? So following precautions should be followed when we use power supply. If we are talking about the input voltage, so use a commercial power supply for the power supply voltage input models with the AC input. Inverters with an output frequency of 50 or 60 Hz are available, but the rise in the internal temperature of the power supply may result in ignition or burning. Do not use an inverter output for the power supply of the product. If you are talking about the grounding, connect the ground completely. Electric shock may occur if the ground is not connected completely. Operating environment. So following point must we take care. First one is what? Use each product within the rated range for the ambient operating temperature, ambient operating humidity and storage temperature specified for that product. Now we are going to discuss about the wiring of the power supply. So first point is use caution when connecting the input cable to the power supply. The power supply unit may be destroyed if the input cable is connected to the wrong terminal. Use caution when using a model with a DC input. Second point is what? The power supply unit may be destroyed if the polarity is reversed. Third point is do not apply more than 75 Newton force to the terminal block when tightening the terminal. Now we are going to discuss about the wiring material of the power supply. Use a wire size that suits the rated output current of the power supply to be used in order to prevent smoking or ignition caused by the abnormal loads. Second point, caution is particularly required if the output current from one power supply is distributed to the multiple loads. Third point is if thin wiring is used to branch wiring, the power supply overload protection circuit may fail to operate depending on factors such as impedance of the load wiring, even when load is short circuited. Therefore, insertion of a fuse in a line or other protective measure must be considered. Refer to the technical explanation for the power supply to the select wiring material. Now we are going to discuss precautions against ingress of the metal fragments. Drilling of the upper section of installed power supply may cause drilling fragments to fall into the PCB, thereby short circuiting and destroying the internal circuit. Whether the power supply cover is attached or not, cover the power supply with a sheet to prevent ingress of the fragments when performing work on the upper section of the power supply. Be sure to remove the sheet covering the power supply for machining before power on so that it does not interfere with heat dissipation. Now we are going to discuss next point, that is charging a battery. When connection a battery at the load, connect an overcurrent limiting circuit and over voltage protection circuit. Fan equipped power supply. Power supply equipped with a fan have forced air cooling. Do not block the ventilation holes on the fan installation surface and the opposite surface. The cooling effect will decrease if the holes are blocked. Always secure the finger guard when replacing the fan. Always turn off the input power before replacing the fan. The input power terminal and internal circuit have high voltage. Next point is do not touch the internal part when replacing the fan. Internal part have high voltage and high temperature immediately after the input power is turned off. Do not allow the removed screw or tools to enter the power supply when replacing the fan. Use the specified installation direction and torque specified for each product when replacing the fan. Now we are going to discuss about the output and ground connection. The power supply output is floating output, so that output line can be connected externally directly to the ground. through the ground. However, the insulation between the primary side and secondary side will be lost. Confirm that no loops are created in which the power supply output is short circuited through the internal circuit of the load. Example, when positive side of the power supply is connected directly to a ground, a load is used for which the internal 0 volt line uses the same ground. Now we are discussing about the overload protection. Power supply often have protection from short circuit or overload that could damage the supply or cause a fire. Fuses and circuit breaker are two commonly used mechanisms for overload protection. A fuse contains a short piece of wire, as I already discussed in the previous lecture, which melts its if too much current flows. The effectively disconnect the power supply from its load and the equipment stops working until the problem that caused the overload is identified and fuse is replaced. Some power supply use a very thin wire link soldered in a place as a fuse. Fuse in a power supply units may be replaced by the end user, but fuses in the consumer equipment may require tools to access and change. A circuit breaker contains an element that heats, bends, and triggers a spring which shuts the circuit down. Once the element cools and the problem is identified, the breaker can be reset and the power is restored. Now we are discussing about the current limiting. Some supply use current limiting instead of cutting off power is overloaded. The two types of current limiting used are electronic limiting and impedance limiting. The former is common on the lab bench PSUs. The latter is common on supplies of less than 3 watt output. A fold back current limiter reduces the output current to much less than the maximum non-fault current. So dear learner, in today's session we discuss safety precautions for using basic measuring instrument for the measure and for the multimeter, and what precautions we should take when we use this instrument. Hope you were able to grasp all the topics nicely. Thank you very much.